Hello guys, I'm Svetlin from SoftUni, the software university. I'm your Java coding instructor and my goal is to teach you to program in Java and start a tech job. As a first step, I teach this series of free Java coding basics video lessons with hands-on practical coding exercises to give you the basic skills of coding, algorithmic thinking, and problem solving. Later, I continue with few more advanced training courses which extend your Java programming skills with data structures, object-oriented programming, and basic Java APIs. Today, I continue my coding Java basics tutorial for absolute beginners, and if you have missed the previous parts of this tutorial, please review them first to catch up. In this lesson, I will talk about advanced loops and how to write more complex program logic which requires nesting of loops, which is basically to put a loop inside another loop or to put several loops inside each other's. I will start with implementing loops with a step and loops which go through a nonlinear sequence, such as the powers of 2. 2, 4, 8, 16, 32, 64, etc. Then I will explain how to use nested loops and the variants of these nested loops. For example, for loop inside a for loop, while loop inside a while loop inside a for loop inside a while loop, etc. I will demonstrate the power of nested loops by many examples and live coding exercises, such as, for example, printing a square of numbers, printing a rectangle of letters, or a triangle of stars with variable size which comes from the user input. At the end of the lesson, we'll solve some hands-on exercises and I will submit the solutions to the SoftUni judge for immediate grading to show you how you can test your code when you solve your coding exercises. But exercises are important. Don't skip these coding exercises. They give you practical skills and experience. To learn coding, you should write code. You should solve coding exercises, write code, run the code, find bugs, fix the bugs, run the code again, find other bugs, fix the other bugs, and so on until you reach a state at which your code works correctly. And this is how developers work their profession. By practice. So, to your exercises. This is how you learn skills. Okay, now it's time to start with the lesson. Let's start with this more complex loops. So complex loops are for loops which may have different steps or might have some kind of more strange or unusual logic which goes from one loop step to another to the next loop step. This is a traditional backwards loop. It starts from n down to 1. It starts from variable I starts from n, for example 100. It repeats while I is bigger than 1 and it decrements the variable I after each step. This is another example where the step is 2. This is another example where the step is the previous value multiplied by 2. So here the values of k will be the values of k will start from 1, then 2, then 4, then 8, then 16, then 32 until it reaches reaches n or something bigger than n. Okay, and another example is something which divides a number n continuously. This is an integer division while it's positive. So for example, if we start from n25, the next iteration will be 12, the next iteration will be 6, the next iteration will be 3, the next iteration will be 1, and the next iteration will reach 0, and the loop will exit at this situation. So this is another way to use a special kind of step calculation process like this formula in order to achieve more complex loop logic.
Usually the last one might be used to find the number of bits in certain number, or number of to find the to convert a number to a binary form or something like this. Okay, so let's see one example as given as a problem and solution. We want to print the numbers from n down to 1. We read an integer and we print the numbers from n to 1 at a single line. So if the input is 100, it should print 100, 99, 98, etc. until 1. If the input is 10, then it will print the numbers 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so how we can solve this? Let's start IntelliJ IDEA. Yes, we still don't have it. It might take some time because it's very good tool for writing Java code and Java projects, but it's a kind of slow because my computer is good enough. It's very powerful with 16 gigabytes of RAM, with SSD disk, with 4 threads and 4 CPUs and 8 threads, etc, etc, etc. But IntelliJ IDEA is very heavy software. So I usually start it preliminary before the lesson, but I forgot to do this before the start. So once it will load, I will create first a project for this. It will be nested. It will be called nested loops, and I will put all my code from today in this project because it is better for organizing my projects into a well-named different projects, one corresponding to each lesson we have. Later we will upload all of this in GitHub, and this will become part of our developer portfolio. So I will create, this is from the while loops, the previous lesson. I will create a new project which will be called something like it will be command line up, something like nested loops Java. It's good enough. This will be the nested loops from the Java lesson. Be sure to have this package as empty because otherwise it will make your job a little bit more complex, but it will still run to a certain extent. I will open this window, and now I'm ready to write the code here in the source folder in this main.java class in this file, and I'll put my logic here. So my logic will be about the printing the numbers from n down to 1. So I'll create a new class called numbers n down to 1. It should be without hyphens and others because this is a class name. I cannot use hyphens, I cannot use spaces here because this will result in error. Okay, this is my class. I'll put main and will create press Ctrl space to use this template to simplify my work, and I will define a scanner. Scanner is equals to Ctrl space scanner. It will be new scanner of system.in. Okay, and then I will say something like int n equals to scanner.read the next integer. Now I have the n and I need to organize the for. I will use for I, which will start from n while I is bigger or equal than 1, and the loop iteration step will be I minus minus. So now I can print I, the loop variable. Let's try to start this and see what will happen. I will enter, for example, as input 10, and it should print the numbers from 10 to 1, each at a separate one. Looks like it works correctly. 10 until 1. So I'm done with this problem, and the important logic here is how to start from n, I bigger than or equal 1, I minus minus. This is a down to and to 1 for loop. Okay, this is the solution I had in mind before the start of this lesson, but it is the reverse condition and decremental I minus minus in the loop. And in the loop body, we need to print at the same line. I'm sorry. So I will print the number, and I will print also a comma and space. So let's see what will happen. And finally, I need to print a new line at the end. But see, if I press 10, it will be 10 to 1. But finally, if I is bigger than 1, I need to put the comma. So I will say something like, if I is bigger than 1, if it's not the last number, I will print a comma after that. Okay, so let's see what will happen now. If I press enter, for example, 20 as input, the numbers from 20 to 1 inclusively are printed here. So we removed the trailing comma here, which is at the last loop iteration. Okay, so we are ready. Here the logic is the opposite. We first print the comma and then the next number. Or either we first print the next number and then the comma. So if we first print the comma, we'll need the comma in all cases except the starting position. If we print the comma after the number, we'll need to print it in all cases except at the last position. So the if here will be different, slightly different, but the logic is very, very similar. So I hope you can manage to write the similar code yourself. And I highly recommend that you write code every day. You need to write hundreds of lines, even thousands of lines of code every day for at least 1 year in order to become a junior candidate developer. Okay, let's go ahead with the next problem. The next problem is very similar. It's about writing a program to print the numbers from 1 to n, but with step 3. This is the example. 1, 4, 7, 10, if the input is 10. If the input is 7, 1, 4, 7. If the input is 14, the output is 1, 4, 7, 10, 13. Numbers 1 to n, step 3. I will copy this. I'll say copy, and I will say, I'll go here at the source, and I'll say paste. And the IntelliJ IDEA will ask me for a class name. So I will enter numbers 1 to n, step 3, because this is what I have. I print the numbers from 1 to n using a step of 3. And I have a copy of this. So the only thing I need to change is the loop. It starts from 1. It ends if we reach n inclusively. And I have I plus equals 3. And I will print the comma only if I is bigger than 1 after the first step. But after yes, I will print the comma before the number, but in all steps before the first. So here I will not have comma, but here I will have after the one. Okay, so let's check whether this works or not. If we have, for example, 7, 1 for 7 works correctly. If we have 20, 1 for 7, 10, 13, 60, 19. If we have -5, the output will be empty, which is absolutely correct. Okay, so we are ready with this problem solution also, and let's check what I had in mind before the start of this lesson. I had in mind this: I read n, then I make a loop from 1 until n with the step of 3. Very similar to what I have written already. And if it is not the first step, I print a comma, then I print the number I, and finally I go at the next one because I want to print the output on a single line and go at the next one. This is the normal process in console-based applications. Okay, so we are ready for the next problem. It's called even powers of 2. It's about writing a program to print the powers of 2 which are even. So we read a number n and we print the even powers of 2 up to 2 at the power of n. So these are the numbers 2 at the power of 0, 2 at the power of 2, 2 at the power of 4, 2 at the power of 8, until 2 of the power of n. So these are the numbers 1, 4, 16, 64, etc. until 2 at the power of n. Okay, let's see an example. If we have 10, the numbers will be from 1 to 124. So this looks like a loop, but the formula to get from one value to the next value is that the next value is 4 times bigger than the previous one. So this one here, this one here is 4 times of the previous one here. This is the formula. And we can organize a traditional for loop, but we'll not have I++, we'll have I multiplied equals 4. For example, if we have 7, in this another example, we'll have the numbers from 1 to 64. Okay, even powers of 2. To solve this problem, I'll create a new class called even powers of 2. And I will put a main method here. I'll press Ctrl Tab to go at the previous class and copy these 2 lines of code because I don't want to type them again. And now I have n, so I will say something like p long. I will use long because 2 raised to some power is increasing very fast, so it might overflow in just few steps. I'll show you. So we have long p, it starts from 1 because 2 to the power of 0 is 1. Okay, so I will start from p equals 1. Oh, I will don't need this, I'm sorry, until I reach this. No, I will need to print all the numbers less than or equal n. I think I will not use 2 to the power of n. I read the number n. Okay, so I will need to repeat this n times. Okay, so I'll have for I from 1 to n, and I'll have I++, and I'll have print p, and p equals p multiplied by 2 by 2 or by 4, which is the same. And if it is 1, if p is 2 at the power of 0, the next p will be p at this power 2, 10, then 2 at the power of 4, then to the power of 6, etc. So this is the formula, and I'll repeat keys n times. Okay, so let's check whether this works correctly or not. I'll run this, and if I have 10, it's 1, 4, 16, but it should stop at 1 at the power of 10. But here I have a step of 2. So here I will need to have a step of 2. Why? Because I multiply by 2, and then again I multiply by 2. So I obtain 2 to the power of 1, then 2 to the power of, okay, it's from 0, 2 to the power of 0, then 2, then 4, then 6, etc. So I will need to have a step of 2 here. The step is 2, and until I reach n. Let me check again. If I have 10, okay, I need to have 10 and inclusively. If I have 10, it will print the numbers from 1 to 124. If I have 7, it should be until 64. Works correctly. So I believe we are ready with this problem. I wanted to show you what will happen if we have big power. It's something like 2 raised to the power of 50. I think this is not big enough, but if I have 1000, see what happens. It works correctly until it overflows. Here the next this number is incorrect, and this is also incorrect. Here we have overflow, and until this number all the values are correct. If we want to solve this, we may use the big, okay, I can show you because this is interesting. Instead of p long, I can use big integer is new big integer of 1. Okay, let's see how I can use this big integer dot 1 or dot value of 1, and then I should say p equals to p dot multiply by 4. Dot multiply of big integer dot value of 4. Let me see whether this works or not. If I have 10, it works correctly. If I have 1000, it still works correctly. You can check. See, Why this works correctly? Because this class big integer holds integer values with unlimited number of digits. So it might be used for cryptography purposes or other mathematical or physical calculations where we need very big numbers. So this is the output here. This is just a small trick. You don't need to know it at this stage of your development as a software engineer, but in many languages we have such classes which allow us to use more accurate integers, because the int, long, float, double and others are limited to a certain number of digits. Okay, let's go ahead. This is the solution I had in mind before the start of the lesson. I start from num1, which is 2 raised to the power of 0. I run the loop from 0 to n with step 2, because at each step we multiply the num by 2 and then again by 2. And we use this trick to use the comma, and the solution is very similar like this. So I can even fix this, print p, and then if p is bigger than, if I is bigger than 0, then I will print also a comma. And now if I need to print the numbers from 1 to 30, 2 to the power of even powers, this is the output. Okay, let's go ahead with the next concept. It's called do-while loops. The do-while loop is something like the while loop, but the exit condition is at the end. See this example. It says start a loop, please repeat this, and finally check this condition. If it is true, repeat the loop body again. If it is false, just exit the loop. Very similar to the while loop, but at the while loop we have the loop body executed 0 or more times, and here we have the loop body executed at least once. So while loop uses an exit condition at the start, and do while loops use an exit condition at the end. So it's a while uses an entrance condition, loop condition, and this uses a post loop condition, post loop exit condition. Okay, so but the logic is very simple. I will demonstrate this to you. So here I can start from int num is 1 to print the number, num equals to 1. Print the number is multiplied by 2, and while the number is less than or equal to 124, for example. So what will be the input? It will be 1, 2, 4, 8, etc. until 224. But this will be always executed at least one, because there is no check at the start of the loop. There is a check at the end of the loop. So this is the do while loop in programming. It's the same in many programming languages like C++, C, C#, JavaScript and others. Okay, let's go ahead with the main topic for today. The main topic for today is about nesting loops. Nesting one loop inside another loop. Let's start from a real world example. Imagine how the digital clock works, or other digital screens. It works as a sequence of iterations. So assume this is the clock, or this is the car fuel indicator, or some kind of measurement. If 1 second passes, this will increase the rightmost digit. After one more second, it will increase the rightmost digit. After this will repeat at each second, for example. Once it reaches 9, it works as the previous iteration, just increase the rightmost digit. But when the rightmost digit is increased and reaches 10, it becomes 0, and the left digits from it it's increased. So we'll have this from 0009, we'll have 0010, 10. So this is a nested loop. Why? Well, because we have this running from 1 until 9. Then, when this reaches 9, this runs from 0 until 9. This also works from 0. Okay? Then, when these two loops are complete, this will run from 0 to 9, and this will become, here we'll have 1, and this will be 0. So we have loop inside a loop. It will be something like this one. We'll have, blue color. 1, 2, 3, 4 until 9. Okay, and we have 1 at the start because, okay, let's again, we have 0 at the start, followed by 1, 2, 3 until 9. Then we'll have 1 at the start, followed by 1, 2, 3 until 9. Then we'll have 2 at the start, followed by 0 to 9. It should start from 0 here also. It's my mistake. And this continues until this reaches 9, followed by the numbers from 0 to 9. So this is a loop. It's from 0 to 9. But this is another loop from 0 to 9. So we have loop inside a loop. And here we might have the third digit, which also starts from 0 to 9, etc., etc., etc. So the concept here is that in order to run this, we might need 4 loops, one inside another. And I will show you in practice how to implement this in Java. Okay? So nested loops by concept are loops staying one inside another. Loop inside a loop. This is a nested loop. Okay? So we can nest loops inside other loops. So if we have something which runs from the first row to row number n, in this situation n is 3, 1 to 3. If we have, for example, a building and it has floor of 1, then it has floor 2, and then it has floor 3. This is from 1 to 3, a loop. Inside, we may have even loop which runs through the locations or columns inside these rows. So we can print the column from 1 to n, and we use an inner loop. So usually in the loop body we can put anything, right? Some logic, some variables. Why not putting another loop? So nested loops are loops which execute some programming logic which also holds a loop. So A typical example is to iterate from the first to the last row, for example, in the cinema hall, and then to iterate from the first to the last column. And currently we just print stars like this, and the outputs is something like this. So we'll have an iteration 1, 2, row 1, row 2, row 3, and for each one we'll have column 1, 2, 3. For the second row we'll have column 1, 2, 3, and for the third row we'll have column 1, 2, 3. Okay, let's see this in action. So I'll clear this code to write the loop. For I, this will be row, it's from 0 to 5, for an example, or from 1 to 5 inclusively. So we can write something like row equals plus row. This is a normal loop. It will print the numbers from 1 to 5 here. Okay, but instead of printing these numbers here, what will happen if we print the columns from the numbers 1 to 5 here? We can either print here 1, 2, 3, 4, 5. Okay, let's see. Or we can replace this with a loop. For column start from 1 to 5, and we print space plus column. It's the same, but now it's with a nested loop. So we have loop which repeats, okay, after that we'll need a new line. We have a loop which repeats 5 times, and inside it we print the numbers from 1 to 5. So first time, second, third, fourth, fifth. At each row we execute this. So I can also print something like row plus column to see what happens. We'll have row 1, the numbers from 1 to 5. Row 2, the numbers from 1 to 5. Row 3, from numbers 1 to 5. We can replace this 5 by n. And now we can have int n is 5. This will be the same logic here. Okay. But we can change this with 4. And now we'll have 4 rows and 4 columns in each row. Okay. And instead of this, we can print, instead of call, we can print an asterisk here. And we'll print a square of n by n stars. Okay, this. I can comment this, and it will be the square from the example of the previous slide. This one. If n is 3, this is something like this. So this is how loops work. Inside the loop, we may have other loop, which is obvious. We didn't need to teach you that this is possible because we already explained that inside the loop we can put any block of code, which may also hold a loop. So let's go ahead with some more concepts. Nested loops are several loops placed one inside another. And nested loops are used to execute multiple times certain action, which itself executes multiple actions. So, for example, we may need to build a building holding n 5 floors, and at each floor we may need to build 5 rooms. So we need for the first floor 1, 2, 3, 4, 5 rooms. For the second floor, 1, 2, 3, 4, 5 rooms. For the third floor, 1, 2, 3, 4, 5 rooms. So these are actions, build a floor, which consist of several other actions, build a room. Okay, so we sometimes need to implement more complex calculations and program logic, and we may need nested loops. Usually, when we have a table holding rows and columns, we need nested loops. This is a very common indication. If we need a tabular data, tables, we need nested loops. If we have cubic data, something like this, this, and this, building of 3 floors, each holding many rooms at several, how to say, if we have multiple tables, in fact, we may need 3 nested loops. So I'll show you this in practice. But generally, nested loops are loops inside loops. A typical situation to have rows holding columns. We have multiple rows and each row holds multiple columns. Let's see this example. In this example, we have floor from 1 to n, we have row from 1 to n, and we have column from 1 to n. We have, for example, assume we have a cinema consisting of 3 floors. At each floor, we have a cinema WAP, a cinema hall, where we have n by n rows and columns. So let's see this. I'll show you. We may have a for loop which loops the floor number from 1 to n. Inside it, we may have another loop which loops the row number from 1 to n. And finally, we may have another loop which loops the column, changes the column consequently from 1 to n. And finally, inside the loop body, we may print the floor number plus a space plus the row number plus a space plus the column number. Let's see how this works for n3. Okay, first floor, first row, first column, first floor, first row, last column. So if we have n4 and each loop is from 0 to 9, from 0 to 9, we'll have something very similar to our example before. Did you remember the example? Let's go back. 0, 1, 2, 3, 4, 5, 7. If it reaches 9, the next is 10. Then 11, 12, etc. It's a counter. Okay? If we reach 0, it increases the previous. So this is how nested loops work in action. You need to have just some practice. By theory, they are nothing complex, but when you practice, you need to just think in the terms of nested loops. Okay, so remember to use different variable names. Sometimes people are trying to copy and paste this and see what happens. This variable is already defined. So the nested loop cannot have the same loop variable like the outer loop. This by the way, this is called inner loop, and this is called outer loop. But this loop here is inner. This loop here is inner regarding this one. So if we have just two loops like this, we have inner, this is the inner loop, and we have outer loop, which is obvious. Let's go ahead with some examples of how to nest for loops inside other for loops. I'll start with the concept. The concept is that we have for loop which holds initialization, condition, loop condition, and increment formula. The outer loop, the inner loop holds the same, and inside these nested loops we have some commands, some statements which are located here. Okay, we may have some commands here as well, which are part of this of the body of the outer loop. Okay, let's see this in practice. We want to print a table consisting of 3 rows, each holding 2 columns. So we iterate for the variable r from 1 until the number of rows. So it will iterate like this: 1, 2, 3. Inside it, I want for 1 to have the numbers here from 1 until 2. For 2, I want to have the numbers 1 and 2. And for 3, I want to have again the numbers 1 and 2. Because I want to have 3 rows, each holding 1 column, 2 columns. Okay, so here I will print the row number, and then this will print something like this. 10, I will iterate from 1 to the number of columns and will print the columns with a leading space here. And this will print this. The inner loop here will produce this. The outer loop here will produce this. At the next iteration, what will happen? This will be, R will be now 2, and the second row will be printed. In the second row, we need to print the columns 1 and 2. They will be printed. At the next iteration, here, the next row number 3 will be printed, and for inside it, this loop will print columns 1 and column 2. So this is how this works. This is a very good example of nested logic, and you can see it many times. For example, if we have a hotel, we have few floors, for example 5 floors, and in each floor we have, for example, 20 rooms. At the first floor we have 20 rooms. At the second floor we have 20 rooms. At the third floor we have 20 rooms. If you want to clean all the rooms in the hotel, we need to repeat for each floor, please, for each room, clean the room. We need to go to the first floor, clean the rooms one by one, go to the second floor, clean the rooms one by one, go to the third floor, clean the rooms one by one. So this is a very good real-world example of nested for loops. And this is an extremely good explanation of how to use this and why they are needed and how to code these nested loops in Java. Okay, let's solve our first problem using nested loops for today. It's about writing a program to print a triangle of stars, just like shown below. If the size is 5, we print 1 star, 2 stars, etc. until 5 is reached. First one, second, third, fourth, and fifth. So we need to have a loop from 1 to 5, and for each row we need to print a stars corresponding to this row number. For example, at row 5 we need to print 5 stars. If the input is 7, if this size is 7, the output should be this one. 1 star, 2 star, until 7 stars. So let's solve this problem. Triangle of stars. We go in IntelliJ IDEA. I will delete this because it cannot compile. I'll create a new class, triangle of stars. Okay. I'll have the main method. I'll copy these two lines because I don't want to write them again. It will take time. So I'll start from, I need the for I template. I'll start from 1 until I reach n I++. So I need to print I stars. Run. For example, if we have 5 here, I need to print 1 star, 2 stars until 5. How do we print 5 stars? I stars. How do we print this number of stars? We make a loop. I can change this variable. Control RR. No. Shift F6. Yes. Stars count. Or it might be 1. And the first one, second one, third one, I print 1 stars. And here I'll need for I. I'll start from 1 to 1. 1 times. I repeat, printing a star followed by space. And after that, I'll print a new line. Let's see whether this works or not. This prints 5 stars and this goes at the next one because after we print 1 star, we need to go there. Oh, we don't need the spaces. Okay, but it's exactly the same thing, just the output will be slightly different. For input 7, I will have 1 star, 2 stars, 3 stars, etc. We can trace this through the debugger, debug, and you'll see what will happen. Now the 1 is 1. Hey, please stop here. Okay, debugger, F8, looks like something is broken. Oh, I needed to enter n, sorry. I need to debug it again. I just needed to enter this 5, for example. So we have F8. Now 1 is 1, and we print 1 star, and this loop ends. Now 1 is 2. We need to print 1 star, then 1 more star, and then we print this. At the third one, we will repeat this 3 times. 3 stars are printed. We go at the next one. At the next one, fourth, we need to print 1, 2, 3, 4 times a star, then a new one. And at the final 1, 5, we print 1, 2, 3, 4, 5 stars, then we go at the next one. And now this loop stops and the program is done. It also stops. So this is how this works through the debugger. Generally, exactly what we might want to expect. Okay, so this is the solution I had in mind before the start of the lesson. I iterate from 1, I enter the size, and I change the row from 1 to size, for example, from 1 to 5. And at each row, I iterate the count from 1 to row. It's not from 1 to n, but it's from 1 to the previous one. So this serves as end value for the internal or nested loop. And after I have printed all the stars for the current one, I go to the next one, because otherwise all the stars will be printed at a single one. It will be just a sequence of stars. So let's say a few words about nested while loops. It's very similar. Like we can have for loop inside another for loop, we may have a while loop inside another while loop. This is how it looks as a concept. We have outer loop. While something is true, please repeat. Inside, while something different is some other condition is true, repeat. And we execute here some statements. We may also here execute some statements and before the loop here, and here we may have also some statements. So we may have statements, while loop, then other statements. Here we may have also something, then another while loop, then another thing. So we can nest while loops everywhere where we can have a statement. For example, inside if, inside for, inside while. Let's see an example. We want to print rows. We have row number changing from 1 until 2, and we print it. Then we have a nested loop which changes the column from 1 to 3, and we print the column number. So for the first one, we have an inner loop which prints columns 1, 2, 3. Intentionally, we have a space here in order to visually demonstrate that this thing is inside the outer loop row. Then we increase the row number, and now the row number, and after that the loop repeats. Now the row number is 2, it will be printed, and this code will loop from 1 to 3 and will print column 1, column 2, column 3. It is very similar with what we achieved with nested for loops, but this is done with while loops. I just wanted to show you that we can put one while loop inside another while loop. Let's solve the previous problem, triangle of stars, but it's the same problem, but using while loops. Okay, I will copy this triangle of stars, Ctrl+C, Ctrl+V, while loop. For example, this will be the name, triangle of stars while loop. Okay, so I read the input and I say int one starts from 1. While 1 is not reached or is within the range of n. If the y is 1, 2, 3, 4, it's not exceeded n, I will print 1 stars. Let's see this. I iterate. Oh, 5. And now I don't increase this one. IntelliJ IDEA says, oh, you don't change this inside the loop. You might fall into infinite loop. I noticed this, but I wanted to show this to you. So 1 plus plus will be needed at the end of this loop. Okay, now I want to have 5 ones. At the first one, I want to print 1 star. At the second, I want to print 2 stars. At the third, I want to print 3 stars, etc., etc., etc. So I need to change this with something different, which will be let stars, not let, int stars is 1. Wow, stars is bigger than 0. I will print a star, then stars minus minus. I want to print this amount of stars here. So I start from this, I print a star and decrease the number. Later, I go to the next one. Now, let's see whether this works or not. 5. Oh, it doesn't work from 1. Why? 2, 3, 4, 5, 6. Wow is bigger than 0. I will print it. Okay, 5. 1, 2, 3, 4, 5. Works absolutely correct. See if we forget to go the next one. We print 1 star, then we print 2 stars, 3 stars, 4 stars, and 5 stars. And if we forget to go the next one, the output will be this. All the stars stay on the same one. So please don't forget. Finally, our complete solution is this code. We start from 1, 1, 1, then we go to 1, 2, 1, 3 until we reach 1n, and we print 1 number of stars of the first one, 1 number of stars of the second one, etc. And we increase. These are nested while loops. While loop staying in the body of another while loop. If we think of this while loop as a black box, so we don't know what's inside, we can construct this outside loop separately, then construct this logic separately, just like it is here. For example, not here, but just like it is something separate, and then we can combine them together. So this is how it works. I believe once you get some more experience, it will be easy for you to work with nested loops. It's not important whether these are for loops, while loops, or other loops. It's the same concept. This is an example. We read a variable called height, which means how many rows we have. We start from row 1 until row height. Row 1, 2, 3, 4. we start from colon 0 and we have this. Oh, this is something interesting. I may have wow star minus minus is bigger than 0, then print this, which is slightly less code. So I decrease the number of stars, and if they are bigger than 0, I print asterisk, but I'm not sure this is correct. Let's check. 5, 1, 2, 3, 4, 5. Okay, so I decrement here in the while loop and then compare whether this is bigger or not. It might be like this also. But the previous one looks better for me. More readable and more understandable. So this is the solution which I had in mind before the start of this lesson. Of course, we may have for loop here. Of course, we may have for loop here as well, because we know in advance how many times we will repeat this block of code. But in this example, I want to demonstrate how to use nested while loops. That's why I solved this problem like this. Okay, let's show how we can nest while and for loops depending on what is more convenient in the current situation. So we can have a for inside a while, we can have a while loop inside for loop, or we may have while loop inside two nested for loops. Let's see this. We want to print, to implement a sum of digits calculator. This program reads integers until end is entered. So it reads, for example, 5, 10, 20. Finally, if you put end, the program will stop. For each integer, we need to calculate the sum of its digits and print them. Finally, we print goodbye. This is an example. We enter 157. The sum of digits is 1 plus 5 plus 7, which is 13. The next number is 99. The sum of digits is 18. 5, the sum of digits is 5. 438, it's 4 plus 3 plus 8, it's 15. And when end is entered, the outer loop stops and says goodbye. This is what we need, sum of digits calculator. New class called sum of digits calculator. Okay. I will put the main method here and I'll have something like while true. I read string input, I'll read the input as a scanner dot next line. Scanner dot next line. I read text because the next line might hold either a number or a text. I'm not sure what it holds. So I read the text, and if the text is end, I will break from the loop. I will stop the loop. And I will print goodbye at the end. Here I'll process the input. See what happened. I created a loop which reads a line. If it reaches end, it stops and then processes the read input. Finally, it says goodbye. This is a portion from the problem. We have, for example, we enter 1, 2, 5. We need to process this input to calculate the number, the sum of its digits, and print them. Then I enter hello. It should process hello. Then I enter 5372. It should process this. Finally, I enter end, and it stops the loop and says goodbye. Now I need to change this with the real logic to calculate sum of digits. In sum of digits as 0, I need to have the number, and num equals to integer.parseInt of this input. So I read the next line. If it is the command end, I stop. Otherwise, it should be a number. I parse this number. For example, this might be this number, 157. I parse this number, and I want to sum their digits. So I say, wow, num is bigger than 0. Sum of digits is increased by the num %n, the last digit of the number, and num equals to num divided to 10. I delete the last digits while num is bigger than 0. And I need to have math.abs. I don't explain this in bigger details because we already have solved this problem in the previous lessons. Do you remember this? We had sum of digits many times. We have solved this problem already. The idea is that we take the last digit, we sum it, and we delete the last digit. For example, if the number is 452, the last digit is 2, we'll sum it here, and the number will be divided by 10 as integer division, and will become 45. Then it will become 4, then it will become 0, and the loop will stop. Okay, so finally I print the sum of digits, and I print the sum of digits. And I use math.abs because this algorithm doesn't work for negative values. So I need just to remove the minus if the value is negative. So I have the previous logic extended with this. This is the inner loop, and this is the previous logic which already was tested and it works correctly. We played with them. It's very important that when you solve a little bit more complex problems, to solve them step by step, to divide them into sub-problems. The first problem is continuously reading a number until end is reached. This is the first problem. The next problem is for given number, calculate and print the number of its digits. For given number num, calculate and print the number of digits. This is a sub-problem. So we have one problem, this one, and a nested problem inside it. In fact, we have two separate problems to solve, and we need to combine them. And this is our solution. Run. It's better to write the code step by step, problem by problem, not hold all the code from as one shot. Okay, if we have, for example, 134, it's 8. It's correct. If we have 55, it's 10. If we have 20, it's 2, the sum of digits. If we have end, it's goodbye. Works absolutely correctly. Let's check for negatives. Minus 45, it should be 9. 0, it should be 0. And minus 1, it should be 1. And end, it should be goodbye. Works correctly, so we are done with this problem. Let's see the solution I had in mind before the start of this lesson. While true, read the next one. If it is sent, break. Later, calculate the sum of digits, like I have shown you, and finally print goodbye. Here, the calculation of the sum of digits is a little bit more interesting. Oh, I need to put this here because it's, how to say, a little bit more tricky, but generally it should be like this. This is the whoop which we use. We start from the input number. While it is bigger than 0, we divide it by 10. And at each iteration, we sum up the last digit to the current sum. This is what we have. It's very interesting. It's these 3 lines, this line, 2 lines, and this line are combined in the for loop here. This for loop combines these lines, so it's really interesting, but we need to be careful with this code because it might be misleading. But it's correct, you can check it yourself. So the concept is again very similar. We have while loop, inside it we have another loop which does some calculation. We read the next one, we check for break, then we take the input number, we sum its digits, and we print the output. And we repeat this again and again until end is reached. Let's go ahead. We don't have more new things for this lesson. Now it's your time to solve the problems. You have live exercises session, and I highly recommend that you go through the homework exercises and you solve them yourself. You learn by coding. Please write code. Please try to solve these problems. And finally, if you have problems, if you have difficulties, watch my solutions. I will show you my solutions after a while, but first do your best to solve these problems yourself. Then you may watch my video just to check your solutions with my solution and think about which is better. You may come up with a better solution than me, and this is obvious because different people think differently. So some solutions might be more easy and obvious for you, some can be more obvious for me, some are easier to understand and shorter and more smart, some are not. So give some time and on practice, try to solve the homeworks, and I will be back after a while to show you my solutions. Now it's time to show you my solutions for the practical problems which you had as assignment to work on. So let's start with the first problem, which is called building. It's about writing a program to print a table representing a building like it is shown below. So the odd floors hold apartments which are numbered like this: A10, A11, A12, etc. They start with the letter A and they have 2 other digits. I will explain later. So even floors hold offices in a similar fashion, and the last floor holds large apartments which are L60, L61, L62, etc. You will see the example. So the identifiers consist of type, which may be A apartment, O office, or L large apartment, followed by the floor number, followed by the office number or apartment or yes, office or apartment number. So we have A, like the type, floor, for example, floor 7, and apartment number, for example, 12. It may be A712. So this is concatenated, and this is an example. So if we have 4 fours here, and it's for 1, for 2, for 3, for 4, and we have 1, 2, 3, 4, 5, 6 apartments per floor. At the ground floor we have apartments, at the next floor we have offices. It's odd floor, floor 1, it's odd, so it holds apartments. The next second floor, it's even, it holds offices, office 2, 0, 2, 1, etc, etc, etc. And the next floor is apartments, the next is offices, and the final last floor, it's L, large offices. So your goal is to print a table like this for given number of floors. For example, floors here are 4, and given number of properties per floor, which is here 6. So if we have 4 and 6, the output will be this one. Okay, so this is an example. As input, we take the count of floors and count of estates per floor, and output is the building plan rectangular table of estates. This is an example: 6 floors and 4 estates per floor. This is the output. Okay, so let's solve this problem building. I'll open my nested loops. Okay, here my nested loops project in the IntelliJ IDEA, and I'll create a new class called building table, for example, or table of building. So the main method will hold my scanner, then and it's something in the clipboard, my scanner, then it will hold something like int floors equals to scanner dot next int, later int estates per floor equals to scanner dot next int, and we'll have a for loop which will start from floor 1 until 4 reaches the floors count, and inside this loop we'll have another loop which will be for the estate from 0 until the estates per 4 minus 1. See, the estates here are 6, so this is from 0 are 4. This is from 0 until 3, from 0 until this number minus 1. Okay, and inside I'll check that if we should check for last floor, if I can do something like string type equals to apartment, but if the it's not 4 shift x6, it should be 4, sorry. Okay, if the floor %2 is 0, this is even floor, then the type should be office. Odd is apartment, even is office. It's all even floor. for office, apartment, and if the floor is equal to number of floors, I will rename this number of floors. If it is equal to number of floors, so this is the last floor. The type should be L, which is the last floor, large apartment L, office O, and apartment A. Okay, so now we have the, why this is under, I don't know why it is underlined. Okay, so next I just need to print the type plus the floor plus the estate number, and after that print one space, and once we pass through all the estates of the floor, we need to print an empty line. I believe I'm ready with this problem, so let's check whether it is correct or not. 6, 4, it should be, let's see if it is 6, 4 from A10 to L60. Oh, this is not the correct one, because the last 4 is, in fact, haha, it is not like this. The last 4 is for 1, so I think we should start from the number of floors until 1 in the down direction. So because we'll first print the last 4, then this 4, then this 4, and this will fix the bug I have. 6, 4, L60 to L63, L60 to L63, A50, O40 to 43, A30, 20, A10, and 20, O20, A10 looks absolutely correct. So I believe I'm ready with this problem, and let's see the solution I had in mind before the start of this lesson. I read the floors and the rooms per floor. I create a for loop starting from the floors until 1, the outer loops which iterates through the floors, then the inner loop iterates through the rooms, and I check if the floor, if we are at the last floor, we print L and the floor and the room number. If we have even floor, otherwise this is else if, we'll print the office. Finally, otherwise we'll print apartment, and this is very simple, I believe, and we print a new line after we print all the rooms from the current floor. So we generally print the table line by line, and at each line we print column by column. The outer loop goes through the table lines, table rows, the floors, and the inner loop iterates through the rooms, which are the columns inside the count inside our for the columns in the table, in the output table. Okay, so we're ready for the next problem, which is called stupid password. Write a program to generate all possible passwords consisting of the following three parts. The first part is even number in the range between 2 and n, even number. The second is odd number in the range from 1 to n, and the third is product of the first two. Really stupid passwords. This is an example. 4312. 4 is even number. This is odd number, and this is 12, which is the product of the previous two numbers. So this is what we get as input. We take as input the number n, and the output should hold all possible passwords from the first to the last. These are the passwords. We have 1, 1. No, we have 11. So we have this 2, 1. This is odd number, even number from 2 to n. This is odd number, and this is the product. We have 2, 3, and 6. We have 2, 5, and 10, etc. And finally, at the end, we have 10. We have 11, and the product 110. Okay, so let's check. This is for 5. Let's solve these stupid passwords. Assignment. Let's create a new class called stupid passwords generator. Because what is this? This is a generator of stupid passwords. So it answers very well on the question, what's this? What's this class? I'll put the main method. I'll take the scanner and this from the previous one, from the previous problem, and this is n. So I read the input data, and I'll need a for loop from 1. Let's go back to the problem statement. Even numbers in the range from 2 to n. Even number from 2 until n with I plus equals 2, because it should go through 2, 4, 6, 8, etc, etc, etc. Okay, so this should be named better. First num. Later we'll have, I can copy this, second number from 1 to n with step 2, because it's odd number from 1 to n. It is again with step 2. It should be 1, 3, 5, 7. Okay, and finally long multiplication equals to first num multiplied by second num, and we print the first num. It should start with space, otherwise if we say first num plus second num plus third plus the multiplication of them, this is a number plus number plus number, the result will be a number, right? I'll show you. This is 5. 5. It is 5, but it should be 2, 1, 2. It is 2 plus 1 plus 2. So I need to have empty string plus this, the result will be string, plus this, the result will be this string, and plus this, the result will be this. So these three numbers will be appended as text. Let's see again. Oh, 5, we have this 2, 1, 2, and the final is for 520. Okay, and I need to print them on the same line. Plus space, I don't need this, plus space, and maybe finally I need to go at the new line. Let's check again whether this works correctly. 5, 6 numbers, and they look exactly the same like the others. And for 11, the numbers are this. Looks absolutely correct. So we are happy to have solved this problem. So let's see the solution I had in mind before the start of this project. It's called stupid passwords. I have the even number from 2 to n with step 2, from 2 until n with step of 2. The nested loop is for the odd number from 1 until n with step 2, and inside I print using a formatting strings. I print just 3 numbers: first number, then second number, then third number, then space. And I repeat this many times in the nested loop, so I print the even number, the odd number, and their product. Okay, so both solutions are correct, and the difference is that we calculate this in a separate variable in my solution, and also the way we print this is slightly different, but the algorithm is in fact the same. Okay, the next problem from your homework and exercises is called magic numbers. It's about finding all 3-digit magic numbers of order n, and by definition a number is called magic of order n if the product of its digits is n. For example, if we have 1, the output should be this. If we have 3, the output should be this. And how we can interpret it, this is this consists of 3 digits: first digit, second digit, third digit, and the product of its digits is n. So this is equal to 1 multiplied by 1 by 1, which is 1. This is 1 multiplied by 1 by 3, which is 3. And this 3 is the same like this 3. So we enter this, and we want to find all sequences of 3 digits, which means a number from 0 to 9, which when multiplied result in this number. Okay, so magic numbers. Let's see new class, magic numbers generator will be the name of the class, because it will generate magic numbers. And I'll take again these 2 lines because they are exactly the same like in the previous problem. So let's have the first digit. For the first digit, d1 should be from 1 until n. It cannot be 0, because if it is 0, this will not be 3-digit number. For example, if we have 1 to 3, this is 3 digits. But if we have 0 to 23, this is 23, which is 2-digit number. So it should start from 1. The second should start from the second digit, should be from 0 until 9. Sorry, this is from 1 to 9, not to n. And the second, the third d3, the third digit, it should be okay, the product of each digits, and the third digit is from 0 to 9. Okay, and if d1 multiplied by d2 by d3, if the product of the digit is and 10, I print this number. I'll use printf with this pattern %t, %d, %t, d1, d2, d3. Let's see whether this works or not. For 3, the output should be this. I have 3. Oh, I don't have this new one here. Let's try again. Okay, 3. Sorry, this was a mistake. 113, 131, 311. Works correct. Let's have 6. Oh, we have more combinations here. These 3 multiplied, these 3 multiplied, and these 3 multiplied, and these 3 multiplied result in 6. I can have if I have 12, there are lots of combinations. If I have 21, I have. But if I have some prime number like 7, it should be only 1 and 7. If I have a prime number like 19, it's empty. If I have 0, it still has some solutions, all the numbers which hold 0. Okay, so we are done with this problem, and let's see the solution I had in mind before the start. The first digit is a loop from 1 to 9. The second digit is a loop from 0 to 9. The third nested loop is from 0 to 9. And if we multiply these 3 digits and they have a value of n, we print these 3 digits joined together one after another. Exactly the same solution which I wrote just now. Travel savings. It's about writing a program which calculates the money collection from multiple travel destinations. I'll show you the example. So we read the destination and the budget. For example, I want to go to Bali and my budget is 5,000. And many times I read the program should read some amounts of collected or saved money until the money are enough. So the idea is that I want to go to Bali. To Bali, for example. It will cost, for example, 5,000. But I don't have 5,000. I save once 2,000. Then I save the next month 1,050. Then I save 3,000. And if I sum these numbers, there will be more than or equal to the budget I need to go to Bali. So the program will accept these values, will sum them, and when I'm ready, it will say, you are ready, please go to Bali. After that, it will read another destination, for example, Mexico, and Mexico might cost, for example, 4,000. And I again collect money, and when the money are enough, I go to Mexico and I start from 0 here. See the example. We print after a while. We print collected sum, where the sum is the sum which is collected until this moment, or going to destination, and we read another destination and budget after all the money are collected. Finally, if the destination entered is and this will end the program. So looks like we have two nested loops. First, we read the destination, we do something, and we read another destination until we reach end. And for each destination, we collect money. I'll show you the example. So we enter Bali, and the budget for Bali is 3,500 in this example. The first savings entered is 800. So we have collected 800 starting from 0 for the Bali budget. Later, we collect or save more 1,800. So together, we have this sum is 2,600. It's still less than the required budget, 3,500. So we need to collect more money. At the next month or at the next moment, we collect more 1,000. So we reach 3,600, which is enough to visit Bali according to our planned budget. So we are going to Bali. And so we have a loop, and this is an inner loop. For the next destination, we enter Brazil. We want to go to Brazil. It's more expensive for 1,600, and we collect 5,000, and they are enough from the first shot. So we collected this, and we are going to Brazil. Finally, we press end, and it's enough. Did we have goodbye? No, we didn't have goodbye. So when we press end, this stops. So we have this, and this as the outer loop, and we have inner loop here and inner loop here, because we enter destination and we collect multiple times money. We enter another destination and we collect multiple times money. We have another destination and we collect multiple times money. Finally, we print end, and the outer loop should stop. Okay, I will show you a solution. I'll write one now. It's called travel money savings. For example, it's the problem about saving money for travel. It's a good enough name. I'll again take this scanner from the previous problem, the previous solution, and now I'll do something like this. While true. While it's true, I'll do the following. String destination equals to scanner dot next line. I'll read the next line. If the destination is end, I'll break. Otherwise, here I will collect money and will enter the destination again. Okay, but for each destination I enter double budget. The budget is something like double.parse of scanner.nextOne. I can't use scanner.nextDouble because it cannot be mixed with nextOne. Do you remember, if you use nextOne, you should use only nextOne. You cannot mix with nextInt to nextDouble. That's why I read the data like this. So I have the budget and collected sum starts from 0. and I say, wow, the collected sum is less than the budget, I will do what? I will collect money. Money or saved amount, and collected sum will be increased with the saved amount, and once the collected sum reaches the budgets or becomes bigger than the budget, it should be done. It should be something like going to and the destination. But before that, I'll print the collected money. Something like collected and the sum of the collected money until now. Okay, looks like it's correct, but I'm not sure. So this is the outer loop, which holds an inner loop. Enter a destination. If it is sent, this should stop. We collect the money, and after we have collected the money, we say going to the destination, and we enter another destination. But the money collection process starts from money 0 until it reaches the budget which is read for each destination. Let's just check whether this works correctly or not. But I started incorrect. I started this magic number generator. I need to start travel money saver. Okay. Let's see whether this works. I want to go to Bali. It will cost me 3,000. Okay. I have 2,000 this month. I have collected. I have 500 the next month. I have collected 2,500. I have 700 the next month. I collected totally 3,200. So I'm going to Bali. Going to Bali. I don't have this exclamation mark, but I continue. I want to go to Mexico. It will cost me 5,000. I have 2,700 the first month, and I have 2,300 the second month. So I collected exactly what I need, 5,000, and I go to Mexico. Oh, this should be printed with 2. It should be like this: %.2f /n, and this should be printf. Okay. Finally, I print end, and this will stop. Now with the fixes, let's see whether this works better than the previous one. I want to go to Sofia. It will take me 2,000. I have 1.5 I have collected 350.50. Okay, and now I collected more, 250. Now I have enough money to go to Sofia. I start from 0. I want to go to London. It will take me 500, depends on where I live, of course. I have 2,000, and this is enough to go to London, and it works. If I start from end at the beginning, it will directly stop the program. So I have solved correctly this program. Let's see what happens here. Wow, not destination, which is, please read the next one, check whether it's end, And if it's not, do this whoop. This is a kind of shorter way to implement these three lines. I'll show you. I'll need this, and wow, this is not equal to end, do the following. But this will not work. First, because this is not correct, I should say equals end, and I should say the opposite. Okay, but I cannot declare this here, so I need to declare it separately and say this. But it should be like this. Scanner dot next one. Okay, so please read the next one. Take the result, check whether it's end. Wow, it's not end. The next one. Please do this. It's a more hacker style way to implement this, but it's correct, and you may see it in your practice because it's very popular in the Java world to have this combination of reading the next value and checking it for some other value. I'll try again. I want to go to Pally. It will cost me 3,000. I have 2,500. I have more 499. I have 0.5 and I have 0.5, and finally I reached 3,000 and I'm going to Bali. I want to go to Sofia. It will cost 1,000. I have 1,200. It's enough. I'm going to Sofia and goodbye. Exactly the same way it runs, but we use this construction. So we read the needed sum. We start from collected sum 0, and while the collected sum is less than the needed sum, we take the next one and add the money, the saved money, and we print how many money we have collected. After we have collected all the money for a certain destination, we print we are going to this destination, and that's all. The next number is called the next problem is called prime numbers. It's about writing a program to print all prime numbers in given range. So we have given range, for example, from 5 to 50. These are the prime numbers in this range. 5, 7, 11, 13, all these are prime numbers. So we need to have a loop from start number until the end number. And inside the loop, if num is prime, then print the number. This is not a code. This is loop for num equals to this range. Okay, but this is the idea that we can use. Just have a loop, and for each number within the range, check whether it's prime or not. If the range is 20 to 30, this is 23 and 29 is the result. Okay, so let's create a new class called prime numbers in range. It's good enough as a name. What does this class? It finds the prime numbers in given range. So this answers the question. I will again take this scanner, and from the scanner I will read int start number equals to scanner dot next int end number equals to scanner dot next int, and I'll have for loop for number is from start number until and number, and now print the number and this. Now this will print all the numbers from, for example, 50 to 100. But I need to print only the prime numbers. So I will change this a little bit. Boolean is prime is true. Each number is prime until proven the opposite. I will need a for loop for the divider, which will start from 2 until the math.sqrt of num. Why? Because if we have a divider, if the number num is equal a multiplied by b, it will be for sure that a is less than or equal to square of num, or b will be less than or equal to the square root of num. If both are less than this, the multiplication will not be true. So we have already solved this problem, how to check whether a number is prime. A number is prime if it doesn't have divisors. It can be divided only by 1 and by itself. It doesn't have dividers which are in the range from 2 until the up to square root of num. So if the divider divides num, if we have a divider, some divider, for example 5, which divides num, this means that is prime is false. And we don't need to continue this loop, so we can break. Otherwise, after the loop, if the number is still prime, we print it. And that's the entire solution. Okay, so we have a loop from the start number until the end number. For each number, we assume the number is prime. We try to find dividers, 2, 3, 4, 5, until the square root of num. For example, if num is 100, the square root of num will be 10. So we'll try 2, 3, 4, 5, 6, 7, and 9, and 10. And if this divider divides num without a remainder, this means that this number is not prime by definition. So we stop the loop and we skip printing this, because this will be false. Otherwise, if this loop checks all possible dividers and none of them divides num, then num will be prime. This will be true and it will be printed. Let's check whether it works correctly. From 1 to 20 works correctly, but it's 1 is not prime. So if we start from -10 to 20, these numbers are not prime. So I need the prime is prime. I need another if it should start from max math.max of 2 and start num. The bigger of 2 and start number. It should start from 2 if the number is not enough. So if we start from -10 until 20, these are the prime numbers. By definition, a number which is less than 2 cannot be prime. The smallest prime number is 2. Negative numbers cannot be prime by definition from the math. Okay? If we start from 100 until 200, these are the prime numbers, and this works correctly. If we have from 20 to 30, these are the prime numbers. This works completely well. If from 20 to minus 20, this is an empty range, there are no prime numbers. From 25 until 25, there are no prime numbers because there is only one number here, 25, which is composite. 5 multiplied by 5 is 25. That's not prime. Okay, so this is the solution, and we can go ahead. This is the solution I had in mind before the start of the lesson. We have start and end. We make a loop from start to end, and we assume the prime. And we start from divider 2. We start from divider 2, and we have max divider, which is a square root of num. And while the divider is less than max divider, if the divider divides num, it's not prime, we break. Otherwise, we increase the divider. This might be done with a for loop from 2 until mat.sqrt of num. So this inner loop might be different, but this works also very well. And finally, if the current number is prime, we print it, and we go after that for the next number. For example, if the current number is 5, the next here will be 6, and this logic will repeat for 6. We're done with this problem, so let's go ahead with the next one. The next one is called unique pin codes. It's about generating unique pin codes, which consists of three digits. Okay, the first is in the range 1 to max 1, the second is in the range 1 to max 2, and the third is in the range 1 to max 3. The first and the third should be even, and the second should be a prime number. But if it is a digit, it's from 0 to 9, okay, because it's digit, single digit. What are the prime numbers in this range? There are 2 or 3 or 5 or 7. There are no other numbers which are single digits and prime in the same time. So we need to have one number, D1, followed by a second number, D2, followed by a third number, D3, and this and this should be even, and this should be even, and this D2 should be one of these numbers. So we need to have 3 nested loops from 1 to max 1, from 1 to max 2, and from 1 to max 3. And we need to check whether the first is even, the second is 2, 3, 5, or 7, and the final D3 is even number. Okay, so we want to print the pin codes in an increased order. If we have 3, 5, 5, this digit starts from 1 to 3, and it should be even, which the only possibility is 2. The final digit is 2 or 4, because it should be in the range up to 5. And the second is in the range up to 5, so it should be either 2 or 3 or 5. So these are the This is the output and this is the explanation. Okay, let's solve this problem, and I'll create a new Java class, unique pin codes, generator. I'll create a unique pin codes generator, which will hold my main method. It will have something like this, but I'll need max1, max2, and max3, and I'll need a for I, which starts from, it should be even, so it should start from it should be digit 1 from 2 until max 1 with step 2. Okay, the second should be the second digit D2. It should start from 2 until inclusively max 2, and if D2 is 2 or D2 is 3 or the second digit is 5 or the second digit is 7, 10, it's even, is prime, sorry. Finally, I'll need another for loop, which is the last digit D3, which starts from 2 until max 3, this is max 2, with plus equal to. Okay, this is D1. The first loop from 2 until max 1 with step 2, which means even numbers. The second from 2 until max 2, and then we check for 2, 3, 5 or 7. So we have D2, which is prime. The third one from 2 to max 3 with step 2. And finally, we need to print these digits together. We have empty string, then we append the first digit to this string, then the second digit to this string, then the first digit to this string, and we are ready. Let's test whether this works correctly. 355 should print 6 pin codes as output. 355, we have 1, 2, 3, 4, 5, 6. Works correctly. I can check also 999. These are all possible unique pin codes within this range. And this should not be bigger than 9 because we know that these D1, D2 and D3 are digits, so they should be in the range from 0 to 9 because that's how digits work. Okay, so we are ready with this problem and we can go ahead. This is the way we solve this. D1 from 2 to max 1 with step 2, D2 from 2 to max 2 with if, and D3 is in this range, and we can check for D2 like this and print. It's very similar to what I had in mind and what I already implemented for you a few minutes ago. The next problem is called letters combinations. Okay, we want to write a program which generates all 3 letter combinations under the certain condition. We have a start letter, end letter and excluded letter. We want to print all combinations in the range from start to the end, excluding X, and finally print their count. For example, the start letter might be, for example, sorry, it might be, for example, C. Okay, might be C. The end letter might be, for example, F. So we have these letters in the range. C, D, E, F. And we have, sorry. So we have from C until F, excluding, for example, G. So we have C, D, E, F, but without D, because it's included. So this is the start letter, this is the end letter, and this G is excluded letter. And we have this letter C, E, F, and we want to have 3 letters combinations. For example, C, C, C. Another example is E, C, F, or C, F, F. These are all valid combinations of 3 letters among this set. Okay? This is an example. If we have from A to C but without B, this means that using only the letters A and C, print me all combinations of 3 letters. And they are totally 8. This is the count of these combinations. How many are they in total? Okay, so I will create a new project and a new Java class, letters combinations, 3 letters combinations. Okay, and I will put the main method, and we'll take this because this will help me to save some time. So I have char letter 1, the first letter, which will be next. I don't have next char, so I'll have the next one, but I'll take the first letter of it, because next one will return string, for example, Peter or hello. But I take the first letter, for example, P or H. Okay, so I have start letter, then end letter, and then excluded letter. And I'll have for loop letter starting from start letter until letter reaches the end letter. Okay. Oh, but it's not letter, it should be L1, because this is the first letter, and I'll have inside if the first letter is not the excluded letter, then I'll have the second letter, L2, from the start to the end. And again, if L2 is not the excluded letter, I'll have a for loop for L3. Okay. And again, if L3 is not the excluded letter, then I'll print these 3 letters. The empty string, append the first letter, append the second letter, append the third letter. Okay, then append empty space, and increment the counter, which will start from 0 at the beginning, and counter is 0. And finally, after all these loops, which end here, we can check, after all these loops, we print the counter, which starts from 0. It should be something like this. We iterate from start letter until end letter, running, excluding the excluded letter. Then for L3 do the same, for L3 the same, and inside we print all of this. Let's see whether this works correctly or not. Please print all letters starting from A until C, excluding P. This doesn't work well. Why? Because this is int. It should be char. It should be character. It should be character. It works correctly, but this print A, 97, it is A, 98 is C, is P, or I'm not sure, but let's check. I want all letters from A to C without B. I have B here. Why? Because this is not checked correctly. I should check L1, L2, and L3 for the excluded letter. Let's check again. A to C without B. Oh, works absolutely correctly. I can optimize this a little bit. I will optimize this for code size, but we'll see. I just combine the checks on a single check. And this. I can do like this. I just use, oh, this is incorrectly, Shift F6 with double T, not triple T. I run the first loop from start letter to the end letter, the second loop from start letter to the end letter, the third loop from the start letter to the end letter, and then I check all of these three letters, whether they are different than the excluded letter, and I print if it is true. Let's run this and check whether A to C without B. Okay, looks that this works correctly, and let's have another example from A to Z without X. Oh, a lot of combinations are out there, 15,000. Okay, let's go ahead with the solution I had in mind. Start at X. I have three nested loops, and I check whether the first, second, and the third are different than the excluded letter, and I print and increase the counter. Finally, I print the counter. Exactly the same solution which I already had in mind. Okay, the next problem is called happy numbers. It's about writing a program to generate all 4-digit happy numbers, D1, D2, D3, D4, for given integer n, such that the first two digits, their sum is equal to the second two digits, which are equal to n. So this is an example. If we have 3, we may have the first two digits, 1 plus 2, this is 3. 0 plus 3, this is also 3. Okay, so These two should be equal to these two, should be equal to this. So if we have a loop for the first digit, it should be from 1 to 9, because it cannot be 0. Otherwise, it will be not 4-digit number, it will be 3-digit number. Later we have this. It should be from 0 to 9. Okay. The next should also be from 0 to 9, and the next should also be from 0 to 9, and then I can have some checks here for these digits. This is another example. Let's solve this. It's very easy. It needs 4 nested loops, but it's very easy. Happy numbers. Okay, I'll create the main method. Then I'll take this number and maybe from this the number n, and I'll have a for loop from digit 1 from 1 until 9, then for the second digit from 0 until 9, and now if d1 plus d2 equals n, I can continue. If I don't even need these brackets, because I have single statement after each for or if. If I have this, I will continue. Otherwise, I don't need to iterate for the other loops, because it's meaningful. So I'll have the other two, d3 from 0 to 9, the third digit. It is d3, and d4 is from 0 until 9, and if d3 plus d4 equals n, then I need to print. What I need to print? The number and spaces. So I will print, I don't need this. Okay, I will print something like empty plus d1 plus d2 plus the third digit plus the fourth digit plus some space. I think that's all. And maybe I need to put the code like this to be more readable, but let's check whether this works. For 3, I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For let's check. I have this here, which is not needed, so this corresponds to this. It's correct. Now the brackets are closed correctly, and I'll try again. For 3, I need to have 12 happy numbers. Okay, it should be print without ln. Let's try again. For 3, I should have 12 happy numbers. 12 happy numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10, 11, 12. This is 3, this is 3. This is 3, this is 3. Okay, if I have 12, there are quite more. Looks correctly, so we are done with this project, with this problem. It is exactly the same solution. The first digit is from 1 to 9. It cannot be 0 because it's the starting digit. The others can be from 0 to 9. I check the first 2 digits, then I try the next in the nested loop, the third and the fourth digit, and I check whether they are correct, and finally I print the result. the next happy number if I have it. So this is very similar to my solution. Okay, this was the last problem from your exercises and homeworks. So let's summarize what we have learned today in this lesson. We learned that for loops can use different steps, like step of 2, I plus equal 2, or the step can be that we multiply the current number by 2 and that we get the next number, or we can even multiply the current number by itself. So this will generate something like 2, then or for example 3, then 9, then 81, etc. if I starts from 3, which is very interesting. So we may have any formula which transforms certain number to the next number in the loop. Okay. Later we learn today that we can nest loops one inside another. We can have we can repeat a piece of code which also holds something which repeats a piece of code. We can iterate through all the rows in a table, and for each row we can iterate through all the columns in the current row. For example, nested loops are used when we process tabular data, process data by rows, and each row is processed by counts. Nested loops, while loops can be used when we have repeating logic with nested repeating logic with some exit conditions, like we read numbers until we reach end, and for each number we do something which requires a nested loop. So it is easy to understand the concept behind the nested loops. It's more complex to solve the problems which we may solve using nested loops, because they require combining loops with nesting loops, with complex if statements, with variables, expressions. Everything we have learned until today from our training course is combined as knowledge, as skills in the current lesson. So if you are very good in the current lesson, this assumes that you know very well the entire training course. And the most complex problems at the exam from this training course will come from this lesson. So be sure that if you want to become a skillful software engineer, that you learn how to use nested loops combined with some ifs and more complex logic in order to solve problems like the examples we had today.
Did you like this code lesson? Do you want more? Join the learners community at softuni.org. Subscribe to my YouTube channel to get more free videos, tutorials on computer programming, Java, software engineering, and many others. Get free access to the practical coding exercises and the automated judge system for these code lessons to evaluate your code from the exercises you write. Get help from the mentors and meet other learners. We will answer your questions. And it's all free, completely free. So join now.